Hello everyone. In this particular subject, IoT sensors and devices, I'm going to be teaching you about the different sensors that are available in the first unit. So the first unit is all about the active and passive sensors, the different types of sensors such as capacitive and resistive type of components available. Then we're going to look into about the surface acoustic wave sensors that are used for pressure, humidity and toxic gases. Later, we are going to be looking into sensors for water pH quality and accelerometer, gyroscope sensors, moisture sensors, Hall effect, and humidity sensors. All of these sensors are going to be used in different applications related to embedded systems, or to be more precise, related to IoT. So we'll be looking into all of these topics in detail. So first we'll look into the topic active and passive sensors, their types, the capacitive and the resistive type of it. So coming into a sensor, what is a sensor? A sensor is an input device which provides an output signal with respect to a specific physical quantity. So this is an interface between the real world and the microcontroller. Whatever real world physical quantity you want to get, that particular physical quantity needs to be converted to a machine understandable format, and that is what a sensor is doing over here. A sensor, it is an input device which provides us an output signal, the output signal with respect to physical quantity, whatever physical quantity it is taking from. The term input device in the definition of a sensor means that the part of a big system, and the big system which I was talking to you earlier is like your microcontroller or the processor over here. Another unique definition for this particular sensor is that it is a device that converts signals from one energy domain to electrical domain. So this one energy domain could be any form. It could be pressure, it could be wind, it could be light, whatever it is. One energy domain, and all of them are converted. Please remember, it could be any one of them, and they are converted to an electrical domain signal over here. The definition of the sensor can be better understood if we take an example into consideration. Okay, so we take an example over here. This is an LDR sensor. You can see the LDR working on here. That when a light is falling on this particular sensor, what is happening over here? The resistivity changes inside over here. So what is the quantity? You can see that it's a physical quantity which is the input over here, whereas it is converted to an electrical quantity over here. And that is what you see over here in this particular diagram. So the resistivity is varying over here in ohms. You can see that the resistivity is 400 over here, and it is changed to 10.43, which is now an insulator when light is off. When light is on, it becomes a conductor having very less resistance over here. Okay. So the simplest example is this LDR. As I told you, this particular sensor is the LDR sensor, light dependent resistor, and it is a device whose resistor varies according to intensity of light, whose resistance varies according to the intensity of light that falls on. So for example, here we are taking this torchlight over here. When the light is falling on the LDR, its resistance becomes very less, and when the light is less, the resistance of the LDR becomes high. So it's vice versa, and that is what I explained to you in this. When a light level of 100 luminescence, that is bright light, is directed towards it, the resistance is 400 ohms. You can see that 400 R over here. But when the light is 100 LX, that is, it is almost off over here, very low light, it is directed towards it. The resistance has given dramatically to 10.43 megaohms. So it is a very good insulator now, which means no current will pass through it. So this is an example where you can use it as a current control switch over here. Okay, so if you're controlling the current over here, you know resistor is a device that controls current. It does not control voltage. Okay, so this can work as a current control device over here depending on the light falling on it. So you can use it in different applications. So this is a basic example of a particular sensor. Now we will look into what are active and passive sensors. Okay. So sensor classifications, there are two major classifications of sensors. One is the active type and the other one is the passive type. Okay. So you can see what are they in different. By the term itself, you can understand them. You look in the first classifications. Sensors can also be classified into many other parts, but many other types. We will look into the first differentiative types, which is the active and passive. Passive sensors are those which require an external excitation signal or a power signal. Okay. So passive sensors, they require an external excitation. That is, a power supply is required over here. Then only this particular sensor will work. Well, that is what you mean by passive. And the opposite of that by default is going to be the active over here. On the other hand, they do not require any external power supply. You can see that there is no external power supply required over here and directly generates output responses according to whatever physical quantity. You can see the same candle is available over here, but to make this sensor work, you require a power supply. But to make this same sensor to work over here, you do not require a power supply over here. That is a difference. But both of these, you see that they have their own multimeter over here. In this multimeter, you're able to measure either the voltage or the current depending upon your choice. But the difference, only difference between active and passive mainly is that they have a power supply over here and they do not have a power supply over here. Okay. So the other type of classification is based on a means of detection used in the sensor. So what type of detection? What is it going to detect? Based on that, they are classified into other categories. So we've just now seen the active and passive type. Now we are going to look into the other types over here. Some of the means of detection are electric, biological, chemical, and radioactive. So these are more, there are many more types. These are the major categories that we normally use in day-to-day applications. Okay, electric, biological, chemical, and radioactive. The next classification is based on conversion phenomenon, that is the input and the output. So based on the input and the output conversion principle, we have the other types of sensors over here. So most common types of these are the photoelectric, thermoelectric, electrochemical, electromagnetic, and thermo-optic. Thermo, you may be aware it is related to temperature, and photo, it is related to light. Electric, you know, it is related to electricity. Electrochemical, you know, chemical over here, chemistry, and magnetic, electromagnetic related signals over here. So these are the different types. Final classification of sensors are the analog and digital. We've seen the active and passive. We've seen another type over here by means of detection. We've seen another category by the conversion principle. And the fourth category of sensor classification is based on the analog and digital sensors. Some sensors give analog data and some sensors give output as digital data. Analog sensors produce an analog output. This output is given to the input of your microcontroller. So a sensor that gives an analog output to a microcontroller is called an analog sensor. That is, it sends continuous output signal. It is not discrete in nature, usually voltage, but sometimes other quantities like resistance also can be given through this, can is an output of this analog sensor. Okay, normally the output of this particular analog sensor is voltage, but resistances also are output. It depends on the resistor manufacturing with respect to the quantity being measured. So depending on that, it is related to current, resistance is the parameter they use over there. Is related to voltage, voltage will be provided at the output accordingly. Next one, we have a digital sensor. In contrast to analog sensors, work with the discrete or digital data. They normally work with discrete data only or digital data, opposite to what we saw there. The data in digital sensors, which is used for conversion and transmission, is digital in nature. Okay, whatever data was converted over here, all of them are digital in nature over here. So these are the different types of sensors available. There are n number of sensors in the world, and these are just a few of the examples that are available. At the commonly used applications. So depending on the commonly used applications over here, we have a few sensors, and they are for measuring temperature, resistance, capacitance, conduction, heat transfer, all these types. A PIR sensors for motion detection. Water flow sensor is, you can see how much of water is flowing through this particular area. Alcohol sensor, you can see police checking people and telling them to blow and detecting whether they have drunk or not. Alcohol sensor, gas sensor, whether carbon dioxide, carbon monoxide, all these gases are there. What color is available around you that can be detected and put to your microcontroller. What is the temperature around you? Why is it raining outside or not? You can keep it in a distant location and you can analyze, okay, from a remote place, that whether there is actually rain happening over there or not. Heartbeat sensor, how much of heartbeat is there, and you have your IR sensor that is for detecting heat, that is movement over here, and this is your two types of the IR sensors. Then you have a touch sensor, which is like your what is a fingerprint sensor. Just you touch it, contact is made over there. Based on the contact, you can do many things over there. Then you have humidity sensor to analyze the moisture content in your air. Then you have the phototransistor, that is the light sensor that we saw earlier in the example. You have the gyroscope, you have the, that is tilt related. angle related examples over there. Soil moisture sensor, in the moisture, how much soil is available over there. You have the ultrasonic sensor, which is the working principle of a bat, in which a signal is transmitted and received back, and the time taken by that is used to analyze the distance between the object and this particular sensor. And a simple ultrasonic sensor over here. You have the IR receiver over here, and you have the thermistor, which is used for measuring temperature. And lastly, you have the proximity sensor, which is used for measuring movement that is available there. So there are many other sensors available in the market. These are just a few of these examples that you can use in can be used in microcontroller based applications. So I hope you're getting a picture of what are sensors and their different types over here. So you may be aware of where to purchase these. These are just a few example links where you can purchase these particular sensors and use them for your personal mini projects or whatever application you want to build up. Okay, so these are a few websites, and everything is available on e-commerce. That when you search over the internet and surf, you will get better options and low prices and high star rating based sensor devices so that you can purchase them. I hope you guys were able to understand the concept till now. Later on, we'll move on to our next topic.